panel session with some of the experts that we have in the room, as well as some others that were here to just discuss, kind of so the audience would have a chance to interact with some experts. So Andrew Blower is going to lead that. So panel members are Kenneth Huntley, Craig Figgins, Kimber Klein, Greg Richards, Sarah Olaf from GPI.
Hello, everyone. I'm Andrew Blower. I'm sure most of you know me by now. But I am the coatings engineer for Oregon Department of Transportation. So I am moderating the session. I'll also be up here to answer questions as well. Just a brief introduction. We see a lot of great presentations about steel preservation, maintenance, repairs, and painting's always a footnote at the end of those presentations, and we painted at the end. But a lot really goes into that, and that's what this panel session's all about, to discuss everything that goes into that. And I do have some prepared questions to kind of prime everything, but really this is for you guys to get any questions you may have answered about the painting process, chemistry. We have a great panel here, and I'll let everyone introduce themselves.
Thank you. I'm Greg Richards. Worked with KTA Tater for 25 years now. Started in the industry doing blasting and painting and inspection and things like that in about 1978, so it's been over 40 years of doing the same thing. I've kind of enjoyed it. I do area management and manage inspection projects and write a few specs and do a little failure analysis and manage customers. So that's who I am and what I've done my whole life.
Just heard from me, Kimber Klein with KTA. Been with the company about 14 years, registered professional engineer in West Virginia, NACE Level 3 coatings inspector. I kind of manage our coatings group, our inspection group.
I'm Sarah Olthoff. I'm with GPI. I'm the National Director for Corrosion Protection for GPI. I started my career in coatings 25 years ago. I've worked in and managed our laboratory where we test industrial coatings for about 20 years of that. In the last 5, I've spent more time with our broader corrosion protection services throughout GPI, so our coatings inspection, cathodic protection, and other coatings related services.
Well, I think you all know me by now, Ken Huntley, I probably, of the panel here, I would qualify as the least expert when it comes to paint. I deal at the end product, putting it on the bridges, so that's about it for me.
Good morning, I'm Craig Figgins with Carboline. I've been with Carboline for 19 years. I've been selling and watching paint dry for 30 years, so I'm not very exciting to talk to. NACE Level 3 coatings inspector. We do a little bit of everything in my job. I sell material, I write specifications, I do some failure analysis, I help develop coating systems. So I don't want to say I'm the expert, but I know a little bit. And I work with Andrew quite a bit. So
I would open this up to the audience if there's no questions. I have some other questions that I can ask to the panel as well. But we're really here to discuss anything that you want to discuss about bridge coatings.
I think Ken touched on this during his presentation with the healthy contingency comment, but how often have you seen or recommend bridges be thoroughly cleaned and inspected prior to the contractor being on site? Like I'm thinking of specifically for girders you can see relatively easily, but like these steel trusses, sometimes they're just packed full of debris and you go into the project and it's like, there's going to be steel repairs, but we don't really know what they are yet.
As I was showing in a lot of the photos that I took, access to a lot of these areas is difficult. A lot of it you don't see until you get in there and start removing components and getting in there and doing a in-depth application. That's where you really put eyes on every component of the bridge. Our bridges get biannually inspected by ODOT. And so these bridges get looked at periodically, but that inspection is primarily just looking at structural components. And with Multnomah County, we have a pretty robust inspection crew. We go out there, we wash our bridges periodically, we do maintenance to our bridges. Right now on the Broadway, we found that on a lot of the rocker bearings, a lot of the bolt connections have rusted in there. And again, these are in areas where you don't see it readily. And when you know you have a problem is when a whole piece, and on these rocker bearings, we have these guide plates, and one of these guide plates completely fell off. And that was the first indication that we had a problem. And so once we start tearing into that, we find that several of these bolts had rusted through completely. And so then that tells us that most likely this same condition exists at other bearings. And so we'll start tearing into those and doing a close inspection. So that's an inspection level that the biannual ODOT inspection doesn't get into. And so it's good to have, with a local agency like this, to have a good maintenance crew that goes out there and does routine maintenance work on these bridges. These are the eyes that are on the bridge on a regular basis. And when these guys are out there doing that work, if they see something, then they'll come back to me as the engineer and say, hey, I saw this. Is this something worth looking at? And then I'll go out there and start opening things up and taking a closer look to find out exactly what we've got going on there. But again, as I showed in some of those photos, even if you know you have a problem, getting access to it on a maintenance level is not always that easy, because you're talking about doing some significant disassembly, repair, and then reassembly. And that's really only going to happen when you go in and do a major rehabilitation project on that structure.
Curious if any others have issues, specifically just with the fact it's just not going to be washed before you get on site.
Yeah, one of the things that he hit on with the biannual inspections, most departments of transportation don't have the funds to do much more than that. What happens, at least in the states I work with, they use a biannual inspection to prioritize the bridges they need to go look at. Once they get that priority stuff, they hire people, mainly consultants. Some of them have their own inspection crews, but they don't try to wash every bridge every year, if you will. But typically, even for our initial inspection of those bridges, when they're trying to decide where to paint them, if the bearings need replaced, if they have members that are deteriorating, there's not any washing that goes on yet, because they just don't have the funds or the people to do it every time.
We're kind of fortunate at Multnomah County because, like I mentioned, we have 6 major structures. 4 of those are movable structures. And so for that, we have to have a pretty robust maintenance team. And I think we have a maintenance team of about 24 people. And so doing regular washings, maintenance, and all of that is easy for us to do. But in addition to what we have in downtown Portland, we have all of East County. And out there we have a bunch of minor structures. Those don't get looked at and addressed quite as regularly. And so we can end up with more significant problems on those bridges. Fortunately, they're smaller structures, and so their problems don't have quite the impact that the downtown Portland bridges would have.
Travis, I just wanted to respond to your question, because in New Jersey, we'd start with a concept development study for a project that, you know, you're going to replace or rehabilitate a bridge, and included in that would be a paint evaluation. That's part of what we did as the owner, you know, so that gets done then, and then they turn that concept development study into a final project.
I had one. I'm a concrete guy, so paint is something I am, deficient in my knowledge. But I'm wondering from a practitioner standpoint, and I love your presentation, Kimmer, about your options. Are there criteria associated with, good reference criteria associated with here's when you should be considering zone, when you should be considering spot, when you should be considering overcoating and removal and replacement? I know those all have economic and engineering and probably broad bridge-specific criteria to it, but is there any reference guides that are common to the industry
I'm
or
not
practice?
sure of a reference guide, but I know KTA kind of did a study, and they kind of showed at 5% you should do this, or less than 5, whatever percentages you are to prolong the life of that. The problem is with the DOTs, they don't want to shut their bridges down, right, every 5 years to take care of that. So what they do is they let it go, and then it's we'll just fully paint it in 30 years from now, right? That tend to be the kind of like the strategy they're following, but with the newer systems, I think they're lasting a little longer. So that's kind of was my point. I think you can prolong these without having to shut the bridge down every 5 years or so. Maybe it's 15. Yeah, exactly. Yep.
Yeah, just to add to what he said, SSPC has a guide out for overcoating, and in that guide, it actually talks about what you should be looking for from an adhesion standpoint, from a thickness standpoint, from the Viz 2 has a amount of corrosion guide, how the percentage. Those type of things are the things you look at to decide spot repair, to decide zone painting, to decide full removal and replacement. Those are the kind of, and overcoating. So there's a criteria in there that they have to meet before you even start making that decision.
Question back here to your right. So we should probably get the Carboline guy talking at some point, but I do want to piggyback onto Travis and Dick's comments, and maybe I know that Ken, on the Broadway, that pack rust mitigation ended up being a huge cost for the county, and I wondered if the KTA and GPI folks had anything to say about best practices for identifying and quantifying pack rust quantities prior to construction, so that that cost doesn't run away from you.
We try to measure it linearly, right, and the special provisions to try to get rid of it mechanically and then seal it. Actually, we'll blast and prime, try to get rid of it mechanically, and then flood it with a penetrating sealer, and then intermediate and top coat, and put an item in there for that.
A question for Ken. With the projects that you painted, what level of paint process did you follow, like the SP3 or SP15 or full?
I'm trying to think of the specs. I can't identify exactly which specs, which level it was.
Also, just curious, was it full removal, or just?
Yeah, we took all the paint down, blast to bare metal. And 10, yeah, SP10. So it was all blasted. All the old lead paint had to come off, and so it was down to bare metal, and then we had to get the primer coat on there as quickly as possible to inhibit any rust issues that could come up on that. So SP.
Yeah, just to interject on what Greg said earlier. Yesterday during the peer exchange, part of the things to consider when you're thinking about overcoating or total removal is exactly what Greg said about film thickness, corrosion, but also with corrosion, is it isolated? Is it scattered? And then when you're dealing with repair areas, you just want to make sure that you keep in your mind when you're doing repairs, anything you really see, you almost want to mentally double it in size, because that's what you're going to get by the time, as Kimmer said, by the time you clean it up, feather it back. So those are the things you want to take into consideration when you're doing your structures like that. Considering if it's going to be a total removal or overcoat candidate or zone painting.
Yeah, I want to go back, make one quick comment about pack rust removal. Our specs, we found a couple things work really well. One, ultra high pressure water. Obviously, it will take it out. 40,000 psi water will take out pack rust pretty well. The other method is saturating and heating the joint. Obviously not too hot. You don't want to damage the steel, so no more than 500 degrees. And then agitating it mechanically, and then going in and moving it by mechanical means that'll loosen up that pack rust nicely, and you'll be able to get most of it out. Now, a lot of contractors don't like doing that. We'll have them remove it to their best of their ability with mechanical means.
Hey, so we've got a bridge that was built in 2008, and it's got sections of paint that are failing already. And is there a way to kind of go and assess like what went wrong, kind of do like a forensic look at it, figure out what part of the process went wrong so we don't repeat it, and then also kind of take a look at the rest of the bridge and kind of anticipate, is it going to start failing everywhere, or is this kind of localized in certain areas?
There's a lot of different assessment tools that you can use when you have a premature failure, but one of the things that I always like to point out to people in a forensic evaluation like this is, look for patterns, paint is going to perform predictably usually. So, if there's specific patterns in the places where it's peeling, that's a good place to start to figure out kind of what went wrong. Sometimes you can see visual contamination on the backside of the paint chips. When it's peeling off, that's usually a pretty good indication of what the problem was. And then, if some of the obvious things don't point to a problem, someone like KTA or GPI, we're happy to come in and do a full investigation and really help you kind of pinpoint what the problem is.
If you decide to do that type of forensic analysis or have someone come out and take a look at it, you want to make sure that they do good and bad areas both. You want samples from the good and samples from the bad so you can compare the samples.
This is for Craig and Sarah. Are there coating technologies out there right now that you believe are being underutilized by the bridge and preservation community? I'll let Craig take it first.
Yeah, I think for specific instances, there certainly are some that are being underutilized. I think polysiloxanes. I think Wynn just talked about FEV fluoropolymers, and in those two specific products is going to be the weatherability, right? Where you've got either a bright dark color that you want to maintain, you need to have excellent color and gloss retention. You don't want to go back and paint, red handrail or a bright red bridge every 5 years because the color is faded. If you have limited access or very difficult access, like where you're showing the picture of the cable wraps, you want to paint that once and not think about it again for 30 years. I think some of the others that are potential going ahead are polyaspartics. Polyaspartics are going to give you a very quick dry application. So if you have limited ability to shut down traffic, an example in Portland would be 405 Bridge, where you've got a very main thoroughfare that would be impacted. You don't want to be able to basically shut down for 8 hours and get back going again. You don't want to have traffic shut down, so the impact would be unimaginable. So if you have a top coat that will dry in a couple of hours, that may be something to look at. I think there's still some additional testing and some long-term thoughts on polyaspartics, but that would be an option to consider. And I also think, you brought up penetrating sealers for pack rust. I do think that's maybe a little bit underutilized because some of those products can penetrate in and almost help to bind some of that pack rust together. And it's not going to be a cure, but it's certainly going to help increase the life expectancy before it continues to grow.
I guess my perspective on the underutilization of products, coming from the laboratory standpoint, I think the majority of states are populating their qualified products lists and using those qualified products that are tested through the AASHTO NCPP program. And I think it's important for everyone to keep in mind that, it is very costly for manufacturers to put systems through the NCPP program. So they're going to select systems that are most likely to sell. That's, not really going to cover every specialty use, so I guess from the laboratory standpoint, look outside of, strictly those systems that are tested through the NCPP program. Manufacturers do a lot of internal testing. There are third-party labs that can vet out some of those same test properties that would be quantified in the AASHTO NCPP data mine system on some of those systems that are not commonly tested through the NCPP program. In the NCPP program, you're mainly going to see those traditional zinc epoxy urethane systems with very little variation. So that was kind of my laboratory spin on that.
Yeah, and in addressing that as a local agency, we work under ODOT's direction. And so for us, deviating from products that are on the QPL is kind of a challenge. The process that we have to go through to get ODOT approval to use something that's not on the QPL is something that we kind of avoid. And, so looking at this new paint product, the polyexcline, or however I can't, yeah, that one. When I look at, in the photos that I showed you of both the Hawthorne and the Broadway Bridge, one is green and one was red. The red one is pretty much orange now, and the green one is a pale green. So the oxidation and the luster loss was rather rapid. And so because a large part of painting is making these bridges attractive and appealing, a product that would have that longer finish coat look would be very desirable. But again, if it's not on the QPL, the chances of that really getting seriously considered is very slim. So it's kind of a vicious circle that we end up in.
The Louisiana DOTD has collected some data. They did a study comparing 24 different paint systems. They compared their approved product list paint systems with some systems with alternative top coat technologies from various different manufacturers. So they did a pretty comprehensive study, and if agencies are curious about that, reach out to Louisiana for some of that information.
One of the things we were able to do, he brought it up on the Sunshine Skyway cables. The FEVE was not on the FDOT's approved products list, so we were able to get with the State Materials Office and put it out as a pilot project, only because they had enough data from other applications that had been used in, especially Japan that he brought up, that they were willing to accept the risk that it would do what they want to get that 30-year luster life.
Similar to what the gentleman just mentioned, we had a bridge in Portland, Ross Island, that was access is very difficult. It's everything is under the deck, and the span is quite long across the river, and we ended up deviating from the ODOT specification to go with the polysiloxane top coat because of it was a very dark blue color, and as I mentioned before, you want to do it once and not have to worry about it again for 30 years. So we were able to make a change in that top coat. The remainder of the system was from the QPL, but we were able to change the top coat. And there were some specific reasons we did that. So I think it's a job by job and case by case basis that you talk about those options. But I do think that there's some definite benefits to looking at other top coat products that are out there.
And part of what made that possible was because that was an ODOT project. When you're a local agency working under ODOT, it's a little bit more difficult to jump through those hoops.
That happened also before I was coatings engineer, and but not to back out of it, I believe some of the history there also had to do with contractor familiarity with that product. You also want to make sure the contractor that's working with that product's familiar with it and able to apply it properly. And that's also a big consideration when working with a lot of these products, making sure that they're familiar with how the product's applied so you can get that service life out of it.
I'm just wondering, when you have a bearing that just consists of a couple of plates and you want to paint it, but you're hardly painting any of it because a lot of it is you just can't get access to. Do you feel like there's a lot of benefit to that, to paint that?
In the bearing that I was talking about, it wasn't a plate bearing. The plate was a plate on the side of the rockers, and it was a lock plate that would allow the rockers to only move so far. But again, outside of on a bearing like that, and again, every bridge has different bearings, and there's a lot of different surfaces and painting applications for all your various bearings. But in the particular one that I was talking about, all except for the rockers, that whole bearing assembly got painted. And yeah, keeping those painted and keeping rust out of there is vitally important to the life and longevity of these bearings.
I'm just asking if it's like really short and you really can't get access to a lot of it, is it still worth it?
Well, on these particular bearings, they're quite large. They're about probably about 2.5 to 3 feet square. They're huge bearings.
Oh, yeah.
Most of the surface you've got access to. But with any movable bridge, like right now talking with the contractor, the biggest area of concern is out at the toe of one of the bascules. Access to getting in there is extremely difficult. And then you've got your center locks, and trying to get in those areas and get all of those surfaces painted is very challenging. And so what we're talking about with the contractor right now about doing is going in and doing a washing and a complete cleaning, and then we'll go into the very tight areas and do an assessment of the existing coating and what possible, so if it does need new coating, then what kind of hand process we can do, or what kind of equipment they can get in there to coat those areas. Those are one of the tightest locations on bridges like what we have, is out there at the toes.
It's too bad Jeff was not feeling well, because I feel like our contractor would speak really well to areas that are hard to access. But yeah, you do need to be careful when you're, because when you're blasting, you can uncover steel with the rebound of that abrasive that you may not be able to get coating to. You can try to get coating in there, but when you're spraying at an angle, you won't get complete coverage of that steel, and you will leave areas open. If you try to flood it, you may not get good performance out of that coating. Get thick coatings in there with defects in them. So you can uncover more steel than you get properly coated in those areas that are really hard to access. So that is a concern.
Not so much for the panel, but maybe the audience. I'm wondering, within the owner agencies, how many have a specific, if you want to call it, asset management approach to their bridges that are steel, that have coatings and, life expectancies and long-term solutions. I don't know if there's, because to me it's such a specialty area that sometimes those resources to do that, and I don't know if maybe some of the consultants involved have been asked to do that, a network level approach to the steel bridges within states. Have you seen that breakout in assessment or asset management kind of approach? And if any owner agencies have done that, I'd love to hear kind of what they've done.
I know we've done kind of discrete looks at it within ODOT, more snapshots, kind of we pulled inspection data and inventory data and looked at when were coatings applied, when we expect them to need to be bridges to need to be recoated or spot painted, or we don't do so much overcoating, and about how much those will cost in the near term, maybe not on a full programmatic level for the whole inventory, but at least on the near term for programming what we think's coming up on that list. So not on a whole inventory asset management level, but we've looked at the whole inventory as snapshots in time and updated that every few years. We'll take another look at it, update it as needed.
We've been asked by a couple of agencies, not DOTs, but like turnpike agencies, and we've had a couple of projects in New York and one in Ohio on their turnpike systems. It's been a few years ago. We've evaluated hundreds of structures on each of them and given them some information from those structures to prioritize their spending, if you will. So yeah, there are some agencies that use that type of system.
And I can go from my history at New Jersey DOT. We did a couple of things. One of the things, and this was prior to me being the state bridge engineer, when the lead problem first came out, we just made a decision that we're going to replace all our lead paints, whether they were good, bad, or indifferent. So we just went through a process. And now, that was well over 20 years ago. And now we have a line item in our capital program every year that's paint bridges. So that there's, it's 5 million, 10 million, whatever it is. I don't know exactly what it is. You could look in their capital program. It's online. They have a bridge painting line item, a federal one, and as well as a state funded one. And they just basically, whatever comes up off their bridge inspection record.
Some of the DOTs that we're working with also will give like $5 million to each district for paint only, so they can kind of inventory what's their most, what's the need right now.
I was hoping Dwayne would still be here, because back when he was our bridge asset manager for Washington, he had it dialed down pretty good. And it wasn't, we could do like with our funding, because we don't have that many steel bridges, but we have a lot of big steel bridges. And so they're the 40, 50, 60 million dollar paint jobs. You know, they take a huge amount of money. And so we have, Dwayne knew, and he always said, you know, we know what to do. We know when we need to do it to be the most cost effective. We're just not funded for it. And so we just had a huge backlog of bridge painting projects. And so we're not getting to them on a timely basis. We're getting to them when there's funding available. So, and I think that's where most states are. You know when and where you want to do it. What we did after the Skagit River Bridge showed what happens when you dig the dirt out and you see what's underneath there and you see the rivet heads are gone and everything else. We got some money to do annual bridge painting on our bridge cleaning on our steel trusses. So I think that's going to help over the long term.
We've worked with many states, you know, a lot of states that do their structural evaluations, right? They'll categorize the coatings, but it's kind of a basic, you know, generic type of rating system for the overall. And then we've come in many times where, you know, you don't look at the obvious ones that are nothing needed to be done or total removal. We'll come in and do a more detailed evaluation of those bridges that are kind of in the middle to see where they need to go about, you know, looking into the areas where you have the packed rust and things like that, where you might have to clean some areas out to get a better look at things. But I think overall, states are doing you know, a much better job with looking at their coating system and taking up the importance of, you know, how important it really is to protect the overall structure itself.
I have another question for the group related to doing structural repairs and painting at the same time. They're largely two different skill sets, right, for painting, and sometimes the structural repairs can be significant. Just curious if you have any like best practices or ideas on how to successfully specify and contract those fairly different types of work. Well, I know, but how do you do that from a contract standpoint, right? Like,
Well, so one thing that we did in our specifications for the Morrison project is we required that the painting contractor have so many years of experience on similar projects to what we had. And they had to have a superintendent that had so many years of experience. And so you can put language in your specifications to help weed out inexperienced contractors. We had one paint project or one rehabilitation project where the painting was a subcontract, and the prime got a bid from a mom and pop paint shop to do the bridge painting work. And they had done home painting, had never painted a bridge in their lives. And I mean, this is two totally different industries. And so this small-time painting contractor came out there with rollers to paint the bridge, and they had naps sticking in the paint on the bridge. And so finally, but they bid it so low, and they thought they were bidding it high. And when they found out what was all involved in painting a bridge, they realized that they were way over their head. So the contractor ended up just paying them the amount that they bid for to leave. Just go away, here's your money. And then they went and hired a painting contractor to come in. And so, yeah, getting a good painting contractor, like for the Morrison, that is the main part of the work. So our prime is Southern Roads and Bridge, that is a painting contractor. For the Broadway, it was mainly bridge rehabilitation, so the sub was the painting contractor, and that was Abbey and Sabota, another really good contractor for paint projects locally.
So regardless of if it's combining painting with steel repair or any painting project, it's a really good idea to include in your specs that they need to be a QP1, QP2 certified contractor. So QP1 is an SSPC quality program for painting contractors in general, and then QP2 is the quality program for painting contractors that are dealing with lead-based paint removal and abatement.
You're talking about kind of two different things, right? Sequencing and contracting. So we see a lot of times unforeseen steel repairs. So after they blast an area, oh, we got a repair here that we didn't know about. Another thing we've seen is they'll blast and prime the whole bridge and then come back and do their steel repairs. And then the painter will come back and intermediate and top coat.
Yeah, I guess being a little bit more of a structure hat on, I was more concerned with having the painters go out and start trying to tie members together and drill into the steel and stuff. Right, so pre-qualifying the painters for sure. Have you also included language to pre-qualify the structural repairs?
I've seen some of that, yes. And it's has more to do with making sure that the people doing the welding are certified welders, and you have somebody on staff that checks the weld procedures, those type of things, if you're going to do any welding on it. For bolting up, just bolting it up, most states that I deal with put some type of plan note in there with some type of sketch to show what they're going to expect for certain types of repairs, steel repairs, because once you blast it, you may find a lot more before it's all said and done. And then when you get there, you should have a line item in there with a pre-established price to do those type of things. And if you exceed the line item, then you obviously get into force account work. But it's a lot easier to put a line item in and then anticipate what type of repairs you're taking to look at, and you can write the language in the contract or in the specification to do that. A lot of times it depends on what the project really is. Like they were talking about in Oregon, if it's a big rehab project, the prime's probably going to be a rehab contractor, and he'll hire a painter. If it's the other way around, like they're doing with Southern Road and Bridge on one project, the large part of the project is painting, but he'll probably have to have a sub that can do steel repairs in there. And you can write it either way you want, depending on who should be the prime.
What about sequencing? It feels like, you know, the devil is in the access, and so for paint projects, you know, the access is generally, you know, once they get their platform set up and their containment set up, the access is really good. But oftentimes you need that kind of access to get in and actually do the structural repairs too. Is there any lessons learned on like the sequencing of that work and spelling out specifically in the plans and specs, you know, what should be done first, what should be done second? Like Ken mentioned, you know, once they do full removal, it's getting that primer coat on as fast as possible. But if you need to do full removal to find areas that need to be repaired for section loss, then do you have to go back and prep those areas again prior to, you know, laying down your primer coat? That kind of stuff is what I'm interested in.
A major lesson learned that we're seeing is the painter will come in and put all 3 coats on, and then there's some deck work that has to be done. Now all that concrete falls down and it hardens up, right? So now it's a battle between the prime and the painter to say, well, who's cleaning this up? How am I getting paid for it? When they start chiseling it off, it's damaging the paint. We've seen fascia girders that have to be completely reblasted and painted with 3-coat systems after it was already done once. So that was a pretty big lesson learned.
You actually hit about structural repairs, you kind of hit the nail on the head. It's really nice when the containment platform's already there for the welders to work off of. And so you can put stuff in the plans to let them go ahead and blast and prime everything and just mark off the areas and leave them. They have to have structural repairs after they blast. Come back, get the structural repairs done, and truthfully, if you can do it, you can almost jump it. You can have the painter just stay ahead, blasting and priming and marking off those areas, and then the welders coming back behind them if it's physically possible. Getting the welding done so when they get to the end and everything's primed, they come back and reblast and spot prime those areas and start with intermediate.
One of the things that we're dealing with on the Morrison paint project right now is we have a lot of steel repairs on the bascule leaves, and a lot of these repairs are actually crack repairs. And crack repairs are really hard to identify with a coat of paint on there. And so what we're doing is having the contractor go in with, once they get all their containment in place, they'll go in and do the blasting, and then we'll go in and do the testing to determine the extent of the cracks, get those identified as quickly as possible, and then get the prime coat on as quickly after that. So for things that you know that you can anticipate, you can kind of stage these things. But a lot of times you'll get in there and you'll find things that you had no idea about. And that's when you have in the field meetings to discuss, okay, what's our approach from here? And it's basically a case-by-case basis of determining what your best approach is going to be to resolve that particular issue. To plan it ahead of time there's too many variables to know exactly how to plan for that.
That's about all the time we have for today. I'll just add to that and just say the most common thing we see is blast and prime. That'll get masked off. Steel repairs are completed. Any prime touch-ups done, and then they'll bring it up to top coat once any rivet replacement steel repairs are done. So, but with that,
Well, the one last thing I'd like to add is with our paint project that we got going right now, our biggest issues are paint supply. With the economy the way it is right now, the contractor is having to suspend painting approach spans and save his paint to paint the bascule leaves. And the other issue he faced was the paint supplier came and let him know that his costs were going way up, and we don't have a cost escalation in our contract for paint prices. So these are two things, if you're getting ready to start a paint project, to look at very closely and consider, because it can be a major challenge.
yeah, thank you, everyone. Those were some other topics I wanted to talk on, but everyone, you did a great job participating. I really appreciate it, and thank you to the panel. That was great.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.